from the virtual disk. Yes or no? Right? Your data is retrieved from the virtual disk. So virtual disk to YAM, YAM to BINET, BINET to PE. This is the vice versa process. Just observe here. Your request and response. Request means insert into your database. Response, how you will get the response? That is self statement. Self statement nothing but from the virtual disk to YAM, YAM to BINET, YAM to BINET to PE. You get the answer. Insert and your data is distribute and retrieval. And the vice versa process with help of your noding. So,
okay.
So here, what happened here, BINET? This is the intermediate layer. This is the network layer and message passing layer between PE and YAM. Vice versa process.
Sure.
And here, Teradata software, simply this is the LAN gateway or channel network at what? Channel drivers. Both are run the software into your network areas. LAN gateway, this is nothing but the connectivity, local server connectivity. Channel driver, this is the connectivity to your client server area. That is the run process. And very
when
important.
we say,
yes.
Nagesh, when we say client server, in this case, probably the, let's say if we connect via a channel, so the mainframe will be the client and the Teradata will be the server?
Yes, you can connect it to your mainframe server. If you have any credential, if you know your credential, connecting in your mainframe server directly to the Teradata. Teradata to your mainframe server or mainframe server to your Teradata service control. You can work on that, both the things. Yeah, Starling, can you hear me? Yeah, Starling.
Now I hear you. I lost you for a
Yes.
couple of minutes.
Some network issue. Why? Because of I'm in outside from hospital. I'm working here. I'm using another network. That's the reason sometimes the network is a failure or something. Right.
Okay.
So here, so here YAMs and PEs are virtual processor. Before that, you are asking some point. Mainframe to Teradata or Teradata to mainframe, you are going to connect. There are no issues, but before that you should have some credential. If you have the credential, you can going to connect your mainframe server. Okay? Yes.
If we have what? I'm sorry.
If you know the credential, you already password of your servers. You are connecting into your mainframe server.
Oh, connection. Okay.
Connectivity. The credential. Right. And here, YAMs are PEs are virtual processor. These both the applications is run under your PDE. Right. It runs under the PDE. And YAMs are associated with virtual disk. What is the meaning of virtual disk here? YAMs are associated. Once our work is over within your YAMs level, so from the YAM to your virtual disk, your data is loading. Let me associate it. Your data is loading into the virtual disk level. Yes or no? Once our data is completed, work is completed within the YAM, you are associated with your virtual disk. Your data is loading into the...
To me, the disk is where data is loaded physically.
Right. Internally, automatically into your virtual disk from the YAM.
Right. Automatically internal. Yes,
right.
Yes.
That is randomly, automatically, equally, that is even, equal data distribution. Auto partition, you can say auto partition. That's automatic partition.
Got it.
And here, this is called as the single node architecture. Single node architecture. This is single node architecture, you can say here.
Okay.
And that is called as the software progressing. 1 second, Stanley. 1 second, please.
Sure. Take your time. Yeah, sure.
Why? Because of I'm working with help of the hospital. See my screen also. You can see my screen here. I work on the hospital. You can see, right? My screen. So 1 second. Yeah. 1 second. Yeah.
Okay.
Yeah, Stanley. Sorry for that.
No problem at all. Someone is sick.
Yeah, actually, my son's surgery they done today. I am in hospital. I work with help of the hospital only.
Oh, okay. I hope he gets well. Yeah.
Maybe tomorrow they can discharge from hospital. Okay. That's the reason. Yeah. Right.
Yeah.
Sorry for that. Yeah.
No problem.
Thanks for that. Only for today only.
No problem. Yeah.
By tomorrow they can recharge. You can find tomorrow. Okay. So I don't want close our class by today. That's the reason I'm working from the hospital.
I see.
I don't give any trouble to my students. That's the reason.
Okay. So, I mean, in Nagesh, in future, if you wanna maybe schedule to the different time, we can work it out if you need to go to the hospital. I mean, it's up to you.
No problem. No problem. Currently, I am in hospital. Currently, I am in hospital only. Yeah.
I'm trying to make it easier for you.
No problem. If any difficulties, I will mail to you or I will inform you before that. Okay.
Okay.
Thanks for your concern. Thank you very much. Right.
Sure.
And here, so the minor surgery will happen to my son. Minor surgery. Okay. Yeah. Right. So
how old is he?
Yeah.
How old is he?
Yes. And here one single node is there, right? This is the one single node architecture. So within the single node, you have the one binary there. The single node is called as the symmetric multiprocessor. That is called as the SMP. Very, very important.
Right.
Very, very important.
Yeah. Is it symmetric or symmetric? What is the proper?
Symmetric or symmetric, whatever way, as per your pronunciation. So,
it doesn't matter.
Symmetric.
So you can say symmetric or symmetric, doesn't matter, or it's
symmetric means that the different things are there. Symmetric is the different things are here. Symmetric means that the parallel is going on. Symmetric means this is a single processor is going on. So here one node So we see the one node is there, right? This is single node. That is called as the symmetric. Symmetric means one. Simultaneous means that the parallelism. That is called as. So symmetric multiprocessor. That is called as the SMP.
Okay.
And within the SMP, you have the one binary there. See, one binary there. So the binary is called as the software configurable binary. Software configurable binary. Very, very important. This is one of the certification question. Very important. So SMP means this is the single node architecture. You call that the symmetric multiprocessor. Within the SMP, we have the one binary there. That is called that the software configurable binary. But MPP means that the multiple nodes massively parallel processing. That's here. Massively. Massively means multiple configuration is going on. Multiple nodes configuration. Within the multiple nodes, we have the multiple binaries are there. Multiple binaries. See, 0 binary, 1 binary, 2 binary, 3 binary. 0 to 3, that is the 4 nodes are there. Each and every node, we have the one binary. Each and every node consists of one binary. If we have the 4 nodes, we have the 4 binaries.
Just one second. I'm looking at picture. Can you bring it down a little bit?
Right.
I see multiple nodes, but you show only binary 0 and binary 1 on a
So here within the diagram 0, 1 you can see, but the upper side and that side, the below side, you cannot see. So actually within the diagram 0, 1, 2, 3. Why? Because of 4 nodes are there. 4 nodes means 0, 1, 2, 3. Each and every node.
So you,
yes.
You need one binary per node in multiple processing, right?
Right. You have the MPP system. You are going to work on the multiple binaries. Within the diagram, you can see only 2 binaries, 0 and 1 only. Yes or no? That side, the below side, the upper side, you cannot see. The upper side is the binary 3. The beside of the one more is there within the diagram. That is square, right? That is square. So that is the rectangle. That rectangle. 0, 1, the below side you have the 3. So totally you have the 0 to 3 is called as the 4 binaries are there. In case you have the 4 nodes.
Okay.
So within the MPP, how many nodes are there? We are going to count it is the multiple nodes. That is called as the, MPP is called as the hardware configurable binaries. Hardware means network, multiple binaries is going to connect. But within the SMP, we have the only one binary. That is called as the software configurable binary. Software means no need to network. Yes or no? No need to go for network area. Single connectivity. But MPP means hardware, network is going on. Each and every binary is going to connect. Right? Each and every node is interconnectivity. Just one more within the diagram. See, binary cabling. That is one of the channel interconnectivity for MPP system. Interconnectivity for MPP system. Yeah. So interconnectivity for MPP system, that is the multiple nodes.
Okay.
And that is called as the hardware configurable binaries.
Okay.
So just remember here, within the SMP, we have the binary there that is called as the software configurable binaries. But within the MPP, called as the hardware configurable binary. This is one of the important interview question and also certification question.
Okay, I got it.
And here, the physical message passing layer is called as the binary. This is the interconnected to multiple nodes. Just observe here. Then binary is connecting into the multiple node interconnectivity. Physical connectivity is going on. That is called as the binaries. And Teradata is linearly expandable. When it is expandable means you are going to add the multiple nodes. See, additional nodes you have to require when your database grows. Last session we were discussing, right? So if you are a database, your database size is increased. You should be added the multiple nodes according to your requirement.
Nagesh, what would be the other word for linearly expandable or linearly?
Linearly means according to your client requirement, you are going to expandable. You are going to add the number of the nodes. For example,
no, I understand that. I just trying to have
No, nothing but here your database is grow. You are added the multiple nodes. That's the thing.
I
that
got
is
it.
called as the linearly. Linearly means requirement. If you have the requirement accordingly, you are expandable. For example, your laptop is 4 GB. You are going to expandable to 8 GB. Yes or no? If you are required, if you are increase the performance, yes or no? That is expandable. For example, your PC is considered 4 GB of the RAM, but you are going expandable to 8 GB. Yes or no? Right? 8 GB RAM size, your laptop. Memory size. Yes, sir, that's what your requirement. That is called the linearly expandable. Yes. Any doubts, Stanley? This point?
No. I got it. Thank you.
Right. Yeah. And here you have the multiple binaries are there that the binary can support V2R5. Very important. 296 nodes. V12, 51 nodes. V13, 1024 nodes. V14, 1024 nodes only. For example, here, see, the binary can support the multiple nodes, maybe according to your requirement. But within your diagram, as shown within MPP, two binaries, 0, 1. But beside you have the 2, 3 also there. Beside as well as upper. Upper you have the binary 3. So totally 4 binaries are there. Binary 0, binary 1, binary 2, binary 3.
Maybe you can edit.
Yes.
Maybe you can edit. Maybe you can edit binary 2 and binary 3.
Right. So within the bracket I can show you binary 3, 2, right? 2. And also binary 3.
Okay.
These all the besides, right? Beside and upper. Beside and lower, right? Lower. Right. Now it's clear? Right?
Yeah.
Binary 2 is the beside and binary 3 is the lower side. The upper lower side.
N, N stands for node, right?
N stands for and.
And okay.
Binary 3 beside and lower. I mean beside and also
And lower.
lower.
Okay.
So these all the points are very important. So main important point here, MPP is configured to the multiple node. That is called as the massively parallel processing. Within the MPP, you call that the hardware configurable binary. In case you have a single node, you call that the symmetric multiprocessor. Within the SMP, you have the one binary there. The binary is called as the software configurable binary.
Okay.
And
Okay.
main differentiation here, SMP, MPP. Now, SMP means you can say single node. Within the other databases, like Oracle DB2 is there, is also supporting the SMP systems. Our Teradata is supporting the MPP system. In case SMP node is failure, what happened within the Oracle or DB2? You have only one node there, right?
Yeah.
One node is failure, what happened? Your
The system is stops.
right, stop, and your data loading the data is going to loss also. Your data also something lost, failure happened.
Or get interrupted, yeah.
Right. So, but within our MPP, there is no issues about the data losing. Why? Because you have the 4 nodes are there. If you have the 4 nodes, even one node is a failure. The failure of the data is migrating into remaining 3 nodes. If your node 1 is failure, what happened? The failure of the data is migrating into remaining 3 nodes. There is no loss of any data. Even your failure node is failure within the MPP system. Right? That is the process. For example, you have the one project is there. Within the project, you have the 4 members are there. Right? 4 members team is there. 4 members, 4 resource of the team is there. In case one employee is resigned, what happened? Your project is not stop. Yes or no? You have the 3 members are there. With these 3 members, your project is going to work. Some button is happened. Something. Yes or no? Standard. So like here, in case one node is failure, your data is not loading into the your data is not loading into the remaining nodes. That is called as the MPP system.
Okay.
Okay. So that's all for today. Actually, 15 minutes more before that. So SMP, MPP, node architecture. So these all the points are very important. Okay. Architecture level. By tomorrow, I can explain the PE architecture. PE architecture. Before that is shown, right? Yes. See here, within the PE, what happened? That is the separate architecture. Separate architecture. PE, that is the parcel engine, binary, YAM, virtualx. These 4 architectures you can go for tomorrow. See, PE, binary, YAM, virtualx. Yes, yes.
1 second. PE, binary, MP, and vdisk. Okay.
Right.
But vdisk is basically storage, right?
Yes, you want storage. How your data is loading? I will tell you that the virtualx architecture. That is also one of the architecture there. See here. Disk level. How your data is loading. Within the virtualx, what happened? See. Distribute the data.
I see.
Right. What is the RAM? What is the RAM? What is the SSI? So, these are the points I can explain by tomorrow, one by one architecture. PE,
Okay.
Client, YAM, virtual disk. This is the individual architectures. Okay. Yeah, Stanley.
Okay, Nagesh. Yeah. Okay.
So
Sure.
yeah, that's all for today. So you
Okay,
can,
thank you. I hope your sound feel better. Okay.
yeah. Thank you for your concern.
Okay.
So we can meet on by
Yeah.
tomorrow at the same time. So already I forward your organizer. Your organizer will forward to you. Okay, the notes.
So yeah, I got it. Thank you so much.
Yeah.